I welcome to all to the course of Transportation Engineering subject. In this session, I would like to explain one of the topic in Transportation Engineering subject, and that is in one of the topic in Unit 5th. So that is payment design. So let's know first what is the unit name of Transportation Engineering. So in Unit 5th name is Introduction to Payment Design. So in this session I will be discuss what is payment design, and what are the types of payments, and what is the procedure of each type of payment, and how many layers of each type of payment will be discussed in this session. So first, what is payment design? So payment is design is nothing but it is a determination of payment thickness. So in payment design, what is the thickness of the payment? So the thickness of the payment, it is mainly depending upon the soil subgrade. If the soil it is the if the soil subgrade is weak, which means the CBR value is low, then the payment thickness will be more. If the CBR value is within the range, then the payment thickness is less. So the payment design consists of mainly for determining the payment thickness or thickness of individual layers. So how many layers for flexible payment or how many layers for rigid payment will be discussed will be later. So but the layers, what is the depth of each or what is the thickness of each layer, so that is the depending upon the payment design. So in this payment only we will consider or we will calculate what is the thickness of each layer. So why it is used for each layer thickness? Because it is serve the traffic for anticipated design period. So this is known as payment design, mainly for determining the thickness of the payment or thickness of the layers. So that is depending upon the soil subgrade, which means if the soil subgrade is weak, the thickness is more, the payment thickness is more. If the soil subgrade is soil subgrade strength, the CBR value of soil subgrade is more, then the payment thickness will be less. So payment thickness determined by based on the CBR value of soil subgrade. So what are the parameters are what are the parameters depends upon the payment design. So the design factors, so the design depending upon the various factors for payment design, such as intensity of traffic, which means how much load is acting on a particular payment. So the intensity of traffic, and intensity of traffic wheel loads, how much vehicular wheel loads we should calculate it before. So that is also main factor of payment design, how much the load is acting on a payment. So that is calculated using the number of vehicles traveling on a particular route or particular path. So based on the survey, we will know how many traffic flow or how much traffic capacity of a particular path. So then next repetitions and temperatures and rainfall. So temperature also mainly affect the payment design. So if the temperature is cool, what type of road is constructed? If the temperature is hot, in those areas of what type of payment and how much thickness is provided. And rainfall areas, so if the rainfall is more, what is the precautions to take in particular areas. So we need to provide drainage drainage flow or path. So then there is no stoppage of rainwater, and humidity also plays a one of the factor of payment design. Frost, drainage condition, and subgrade soils, and we already discussed it. So payment design, one of the main factor is subgrade soil strength and properties of materials. So what type of materials we are using in the payment designs, which means either it is, if it is a flexible payment, bitumen, and what is the property, or if you use the tar, what is the property. or crumb rubber or other pavement materials, what is the properties, or if we use a rocks or stones, what is the properties. So properties of materials also one of the factor, one of the main factor for pavement design. And the criteria for mixed design, so what type of mixed design will consider an economical consideration. So these are the main factor which are influencing the pavement design. The next, what is pavement? We already know that a pavement is nothing but a road made by number of layers is known as a pavement. A road made by number of layers is called pavement. So a highway pavement is a structure consisting of a superimposed layers of processed materials above the natural soil subgrade. We already discussed pavement is nothing but number of layers on a road. So what type of, how many layers will be discussed. So about layers, and natural soil subgrade whose primarily function to distribute the applied vehicular load to the subgrade. So here the main concept is the vehicular load is applying, our vehicular load is distributed to the soil subgrade. So in between soil subgrade we have also layers in between soil subgrade and surface. So the pavement structure should be able to provide surface acceptable riding quality. So we should provide a proper riding quality and adequate skid resistance. So skid resistance also we should provide, and favorable light reflecting characteristics and low noise pollutions will be provided. So this is meaning of pavement and its characteristics. The next, what are the types of pavements in pavement design? So in pavement design we have three types of pavements based upon the structural performance, which means based upon the loading condition or other factors. So based upon that structural performance of the road, there will be three classification. One is flexible pavement, second one is rigid pavement, and third one is composite pavement. If you observe in the diagrams, each method separate diagram is there. For example, flexible pavement, the first diagram is there, so related to bitumen. And second, flexible pavement is nothing but bitumen roads. Rigid pavement is the second diagram. The example for the rigid pavement is CC road. So we can clearly understand the second diagram. So the example for the CC road, and the third diagram composite pavements. Composite pavement is nothing but two or more materials. If you use two or more material, then it is considered as a composite materials. So third diagram is about composite pavement. First, flexible pavement. What is flexible pavement? So flexible pavement is already discussed. It is a bitumen roads. So flexible pavement will transmit the wheel load stress to the lowest layer by grain to grain transfer through the points of contact in the granular structures. So in flexible pavement design, or in bitumen roads, we have four layers. So one is soil subgrade, second one is base, and third one is base, and fourth one is surface course or wearing course. These four names from the bottom. So the wheel load acting on the pavement will be distributed. So the load is distributed, and one by one, and the area or the stress. So what these two factors, how the influence? We know the stress is equals to load by area. If the area is increasing, the stress is reducing. If the stress is increasing, means area is reducing. So a wider area, the stresses will be decreases with the depth. So flexible pavement normally has a many layers. We already discussed, we have a 4 layers. Design of flexible pavement uses the concept of layered system. So layered system based on the flexible pavement may be constructed a number of layers, and the top layer has been the best quality, that is a surface layer. So the top of the flexible pavement is constructed by bitumen. The next, we already discussed it, we have 4 layers in flexible pavement. So those are we can observe in the diagram. soil subgrade and selected layer, which means subbase, then base and surface layer. So if you observe the first diagram, there is a wheel load is uh, acting on a layers. So when the load is acting on a layers, uh, the area the area is increasing towards the bottom layer, that is soil subgrade. So if the area is increased, which means the stress is decreases. So the first diagram, it indicates the load distribution pattern and those layers names. The second, if you observe the second diagrams, so we have a 4 layers. So those layers, so how much depth is provided for each layers. So if you see in the diagram, surface course 25 to 50 mm is provided, and surface course or binder course is same, and 50 to 100 mm, and base course 100 to 300 mm, and sub base course 100 to 300 mm, and compacted soil subgrade 150 to 300 mm. So the first primary coat or a tag coat. So those are the difference between the surface course and binder course, tag coat or primary coat. So this is the typical cross section of a flexible pavement. The next, rigid pavement. Rigid pavement is nothing but it is example is a CC road. Rigid pavement have a sufficient flexural strength to transmit the wheel load stresses to a wider area. So if you observe in the CC roads, they have a more strength compared to the bitumens, so their lifetime also more. So the stresses distributed in the area will be less, and also uh, decreasing a stress levels in the lower of the pavement. A typical cross section of the rigid pavement compared to the flexible pavement. Rigid pavement are placed either directly prepared by soil subgrade or one single layer, which means in flexible pavement we have a 4 layers, but rigid pavement there will be 3 layers is sufficient, which means soil subgrade, subbase or base course, then top layer is a slab. So which means if you observe in the concrete and subgrade, this layer can be called as a base course or subbase. In rigid pavement, load is distributed by slab action, but in flexible pavement, load is distributed by area, which means layer by layer, area by area, or length by length. But in rigid pavement, the load is distributed by the slab action. So the load is only slab area only. So pavement behave like a elastic plate resisting on a viscous medium. So this is the diagram of rigid pavement. So if you observe in the diagram, bottom has a soil subgrade and base or sub base course, either base course or sub base course, so only one course only. So those thickness is 100 to 300 mm, and the top layer, the Portland cement concrete is used in the top layers, that is considered as a slab. So this is the typical cross section of rigid pavement. So constructed by Portland cement should be analyzed plastic theory instead of layer theory. That is a layer by layer in flexible pavement, but rigid pavement is a plastic theory. So the plastic, how much the variation of elastic medium, and what is the temperatures variation. So in those conditions, how the slab is exhibits, and it results to the tensile and flexural stresses. The third one, the third pavement type of pavement, that is composite pavements. A composite pavement is a type of pavement that utilize two or more, so two or more materials. That is known as a composite. So the two are means asphalt and concrete. Typically, a concrete based layer provides structural capacity, while an asphalt surface layer provides a wearing surface course. While designing the composite pavement structure, the flexural strength of the base slab and treated a granular material should be taken into the consideration for tensile stresses. So in the last rigid pavement also we discussed as a tensile stresses, and composite pavements also is a tensile stresses. So the wearing course of the pavement, or the the top surface of the pavement is constructed by spreading bricks or precasted rectangular cement concrete blocks. So those concrete block, there is a gap is there, that joint between them are filled with fine sands or standard gradation. So this is the diagram of composite pavement. So soil subgrade is the bottom and crushed aggregate is the subbase. And surface course, there will be two surface courses, which means two materials are used in the composite pavement. That is, one is asphalt and second one is existing concrete pavements, which means same rigid pavement, but one extra course is added, that is asphalt is added. So an example for the layering one type of composite pavement. So after that, what are the factors affecting in the design of the pavement? We already discussed in the startingly. So wheel loads, axle configuration, contact pressure, vehicle speed, repetition of loads, and subgrade type, and temperature and precipitation and traffic. So wheel loads, how the wheel loads are acting, what is the thickness. So the thickness is based upon the how much load is acting on the pavement, and the wheel load, it is at a particular point on the pavement deformation. If the vehicle contain due to wheels load, one side axle converted into the that is one side of axle then converted into equivalent single wheel loads. So this is the diagram of thick structure and thin structure. This is the wheel loads and pavement, the layers, the wheel load is acting. So this is the ESWL concept, which means the one axial load is converted into the equivalent single wheel loads. So the to carry a maximum load with a specified limit, to carry a greater load due to wheel or dual assembly is often used. So what are the main factors involved in the ESWL concept? So equivalence concept is based on equal stress, contact area, influence 45 degrees, and soil media, which is homogeneous elastic condition. This is the Boyd and Foster method. There is a formula for ESWL method. P is nothing but load is acting, the wheel load. S is nothing but center to center distance between the two wheels, and D is the clear distance and between two wheels, and Z is the desired depth. So there is a formula for equivalent. So what are the materials characteristics? So what are the materials used in the three types of pavements, and what is the characteristics of pavements? So the following material properties are very important, both flexible and rigid pavement. Most of the cases flexible pavement and rigid pavement also is there. So composite pavements only in rare areas that method is used. So when the pavements are constructed in the linear elastic or elastic modulus or Poisson's ratio of subgrade, and each component must be sufficient. So these some are the elastic modulus and Poisson's ratio and linear elastic. These will be some properties. If the elastic modulus of the material varies with the time loading, resistance modulus, which is elastic modulus under repeated loads, may be selected according to with the load of duration corresponding to vehicle speed. So elastic modulus, how the behavior of elastic modulus when in CC roads or rigid pavement. So if it is a non-linear elastic state, how the resilient modulus and what type of stresses will be developed. So what type of stresses must be provided. So many of the material properties used in the viscoelastic models, which are the complex in nature. So this is about the material characteristics of pavement design. So this is the tire pressure and contact pressures. So what is the tire pressure? How much tire pressure based upon the ASTO, American Association State Highway Transport Officials. There is abbreviation of ASTO of road test. Tire pressure was used ranging between 0.515 to 0.55 MPa. The tire pressure in the commercial highway vehicles vary from 0.7 to 1 MPa megapascals. So the tire pressure formula, how we will calculate, it is a ratio of wheel load to the contact pressure. So wheel load, we already know that how much load is acting on a particular pavement, how much weight of the wheel load, and contact pressure is nothing but is the ratio of normal load to the contact area. and which is the sum of in front of rear and uh, front areas. So this is the concept of payment design in the topic of type of payments.